Today we're talking about parallel lines and transversals. So we're going to identify what a transversal is, and then we're going to look how when that transversal intersects two lines, we're going to name the different angles that it's formed. And then we're going to learn a postulate called the parallel postulate. And then we're going to identify congruent pairs of angles and that are formed whenever you do a transversal through parallel lines. So a transversal is just a line, okay? So a transversal is a line, and this line is actually going to intersect two or even more than two coplanar lines, so lines that are in the same plane. So a transversal is just a line that's going to intersect two or more other lines, but when it intersects, it has to intersect in two or more points. Like it can't just be one point. It has to have intersect two or more. So when we look at A, B, C, and D, A is a good example of a transversal, and so is B. However, C, because it is only intersecting at one point and not 2 points, like that would not be a transversal. Those are actually concurrent lines. And then D is another example of a transversal. So we have a definition for what's called an alternate interior angles. So those are going to be angles that are on opposite sides of the transversal. That's where so opposite sides of the transversal, but it's going to be in between the other two lines. So they're opposite, so that's why it's alternate, and they're in between, and so that's why it says interior. So alternate, so opposite sides of the transversal, interior, in between the other two lines. So again, we're looking for alternate, so opposite angles, but inside the other two lines. So if here's one line and here's the other, in between those two lines are these angles here, 3, 4, 5, and 6. So alternate would be on opposite sides of the transversal. So we're talking about 3 and 6, or 5 and 4. So 4 and 5 are alternate interior angles. And then another example would be 3 and 6. Those are also alternate interior angles. Alright, so another type of angles formed by a transversal are called alternate exterior angles. So they're still opposite, but those are going to be on the outside of the other two lines. So here's the two lines, right? So we're looking on the outside. So either 1 and 2 or 7 and 8. Those are all exterior angles. So if we want to do alternate exterior, we're going to do 1 and 8 or 2 and 7. So again, 1 and 8 is an example of alternate exterior, and 2 and 7 is also an example of alternate exterior. All right, our next definition is corresponding. So those are going to be on the same side of the transversal, and they're also going to be on the same side of their respective lines. So there's not alternate, and they're going to be on the same side. So if they're on the same side of the transversal and they're on the same side of their lines, that would be, an example would be like 1 and 5. So 1 and 5 are on the same side of the transversal, but they're also on the same side of their line. Like this is on this side and this is on this side. So they're corresponding. Some more examples would be like 2 and 6. Again, same side of the transversal and then on the same side of their lines. And then 3 and 7 is corresponding. Also 4 and 8 are corresponding. All right, so let's do an example problem. We want to say what kind of angles are angles 9 and angle 11. Okay, so angle 9 and angle 11. The answer is corresponding because if you look, we have this transversal here. Here's our transversal. 9 and 11 are on the same side of the transversal and they're on the same side of the corresponding lines. Like this is left of its line and this is left of its line, but they're both on the same transversal. So they would be corresponding angles. All right, what about angles 4 and 12? So 4 and 12, if you see they're on alternate, right? So they're alternate from the transversal, and they're inside the other two lines, so that means they're alternate interior. So angle 7 and angle 2, so those are alternate because 7 is on this side and 2 is on this side. But see how they're on the outside of the other two lines? So that's alternate exterior. All right, so our first postulate is called the parallel postulate, and that says that two lines that are intersected by a transversal are parallel if and only if their alternate interior angles are congruent. So if you have alternate interior angles and they're congruent, which means they have the same measure, then you have parallel lines, and vice versa. So parallel postulate, if two parallel lines are intersected by a transversal, then the alternate interior angles are congruent. And so since it's if and only if, it also works the second way, which is if you have alternate interior angles are congruent, then the lines are parallel. So you can go both ways on this postulate. There's also something called the historic parallel postulate that says that given a line and a point, and so the point can't be on the line, so you're given a line and then a point that's not on that line, there's only one line that will pass through the point that is parallel to the given line. We also have a theorem that is called the alternate exterior theorem. Which is very similar to the parallel postulate. It just says two lines intersected by a transversal are parallel if and only if alternate exterior angles are congruent. So remember, the parallel postulate, that one had alternate interior angles. And then the theorem is if you have the exterior angles. So that's the difference between the parallel postulate and the alternate exterior angle theorem. So because the alternate exterior angle theorem said if and only if, that means it works two ways. We first have the conditional statement that if two parallel lines are intersected, then the alternate exterior angles are congruent. But it can also work backwards. If you have a transversal and the alternate exterior angles are congruent, then you have parallel lines. All right, so we have another theorem that says corresponding angle theorem, which says that two lines intersected by a transversal are parallel if and only if the corresponding angles are congruent. So remember, corresponding are on the same side of the transversal, but with corresponding to the lines. So if you take a look at example 2 in your textbook, you can see a good example that talks about the corresponding angle theorem. So go ahead and take a look at that and make sure you write it down. And then we have theorem 6.14 that says if a transversal is perpendicular to one of its parallel lines, then it has to be perpendicular to the other line as well. You're going to look more and learn more about this theorem when you try to do exercise 24. And the last theorem is that if two coplanar lines are perpendicular to the same line, then they have to be parallel to each other. And so if you will go ahead and open your textbook and look at example 3, and that's going to discuss that theorem a little bit more. So definitely write down example 3 from your textbook. All right, go ahead and try some problems.